equals to under bracket 1 by pi kt to the power 3 by 2 into 2 pi del by del epsilon under bracket e to the power minus epsilon by kt into root epsilon equals to 0 equals to under bracket root epsilon into under bracket minus 1 by kt dot e to the power minus epsilon by kt plus e to the power minus epsilon by kt into 1 by 2 root epsilon equals to 0. Solving we get epsilon pr equals to 1 by 2 kt. Answer. Hence the most probable velocity is not equal to the epsilon pr. What fraction of monatomic molecules of a gas in a thermal equilibrium passes kinetic energy defined from the mean value by delta n 1.0% and last. The mean value of kinetic energy for a monatomic gas molecule is given by average epsilon equals 3 by 2 kt and from the Maxwellian distribution of velocity d and v equals to n dot under bracket m by 2 pi t to the power 3 by 2 into e to the power minus mv square by 2 kt into 4 pi v square dv. Now converting this equation in terms of epsilon equals to 1 by 2 mv square. So differentiating d epsilon equals to mv dv. Hence dn epsilon equals to n into m under bracket m by 2 pi kt to the power 3 by 2 into e to the power minus epsilon by kt into 4 pi into 2 epsilon by m into d epsilon by mb equals to n into under bracket m by 2 pi kt to the power 3 by 2 into e to the power minus epsilon by kt into 4 pi by m into d epsilon 2 epsilon by m under root 2 epsilon by m equals to n into under bracket m by 2 pi kt to the power 3 by 2 into e to the power minus epsilon by kt into 4 pi into 2 epsilon by m into root m into d epsilon. dn epsilon by n equals to 8 pi epsilon by 2 pi under bracket 2 pi kt to the power 3 by 2 into e to the power minus epsilon by kt into d epsilon by under root 2 epsilon. Hence fraction of molecules dn epsilon by n equals to 8 pi root epsilon by root 2 into 1 by under bracket 2 pi kt to the power 3 by 2 into d epsilon e to the power minus epsilon by kt. Hence d epsilon equals to delta n into average of epsilon. Hence dn by n equals to 8 pi root epsilon by root 2 into 1 by under bracket 2 pi kt to the power 3 by 2 into e to the power minus epsilon by kt into delta eta dot 3 by 2 kt. Solving dn by n equals to 3 root delta pi into e to the power minus 3 by 2 delta eta. Hence epsilon equals to, since epsilon equals to 3 by 2 kt. What fraction of molecules in a gas at temperature T has the kinetic energy of translation motion exceeding epsilon naught if epsilon 0 is very greater than kt? From previous question, dn by n equals to 2 pi under bracket 1 by pi t to the power 3 by 2 into root epsilon into e to the power minus epsilon by kt d epsilon. Now if the total molecules fraction is to be calculated in such a way that the minimum energy epsilon 0. Hence delta n by n equals to 2 pi under bracket pi kt to the power 3 by 2 integration from limit epsilon naught to infinity root epsilon e to the power minus epsilon by kt d epsilon. The principal contribution to the value of integral is provided by the smallest values of epsilon, namely epsilon equivalent to epsilon 0. The solely varying factor root epsilon can be taken from under the radical sign if ascribe the constant value root epsilon. Then delta n by n equals to 2 into under root epsilon naught by k pi t into e to the power epsilon 0 by kt. The velocity distribution of molecules in a beam coming out of a hole in a vessel is described by the function v equals to a into eq e to the power minus mv square by 2 kt. That is the temperature of the gas in the vessel. Find the most probable values of a, the velocity of molecules in the beam. Compare the result obtained with the most probable velocity of molecules in the vessel. B, the kinetic energy of the molecules in the beam. According to the question, the velocity distribution of molecules in the beam is given by f v equals to a into vq e to the power minus mv square by 2 kt, that is the absolute temperature. We have to calculate the most probable velocity of the molecules in the beam. For this, del by del v fv equals to 0.